In neural network, bias has a very important role in overall model architecture. So if you look the output of any neuron within the neural network, it's a combination of weighted average of the input plus the biases. And once this value would be calculated, it would be passed through the activation function, and which is the actual output of that neuron. In this video, we will see how the model performance would be impacted if we remove these biases from the model architecture, and what is the significance of using this bias within your model architecture, and how it helps neural network to create a more complex model decision boundaries. So let's start. So first, we'll import all the required packages for building neural network, which includes TensorFlow, and I am mainly using TensorFlow Keras. Okay. After that, I will generate data for my model training. I will run this statement, and it will produce a training data which contains 2000 samples, and it will have two features. Okay. Next, we'll simply plot it. And from this diagram, you can see that my training data contains two different classes, and which is represented by different color in this plot. Okay. Next, I have defined a small function which contains all the logic required for building neural network, and also it contains logic required for compiling and model training. Okay. So it's a very small neural network which contains one hidden layer and which has one input layer and one output layer. Okay. Next, we'll simply run it. Okay. And now we'll try to explore the impact on model performance based on the bias value. Right. So first we would be calling this function where the bias value would be true, and where we are using this bias. This bias has been defined within dense layer. So here you can see that use bias equal to bias, and whatever value we would be passing from here, it would be populated here, right? So in first case, the bias value would be true, and now we'll see how it will impact the model performance. So we'll simply run this cell, and here you can see that the performance of my neural network is good, and the accuracy for my model is 99.3, so which is very good, right? So for 10 hidden neurons, my model would be able to reach 99.30 accuracy. And now what we will do, we will simply remove this bias, or we'll set the bias value as false, and then we'll see how it will impact. So we'll come back to the explanation later. First we'll try to execute it, and then we'll discuss about the possible root cause, why it happened. So here I have defined the bias value as false. So we'll simply run it. And here you can see that the performance of my model has been decreased, and the model accuracy is 52.55, right? So with the help of only this small changes, my model is not good enough to find out the non-linear pattern within my data, right? And now what we will do, we will increase the number of hidden neurons, and then we'll see whether increasing this number of neurons will have any impact on the model performance or not. Once we'll have the value as false for bias, we'll see. So here I have increased the value of hidden neuron to 100, but we'll keep the bias value same as false. Now we'll run it. From the output, you can see that accuracy of my model hasn't increased by simply changing the value of hidden neuron from 10 to 100, right? So initially it was 52.55 when my hidden neuron was 10, and this time the accuracy of my model was 52.2, right? So which means that increasing the number of hidden neurons will not have any impact on your model performance, because here we have kept the bias as false. So which indicates that the bias has very important role in deciding the model behavior with respect to your decision boundary. And from this diagram, you can clearly see that the decision boundary is not complex enough to segregate my data classes, right? So here the decision boundary is very simple. In this case also the decision boundary is very simple. It's not complex enough to identify the pattern. But once the decision boundary for the model trained with bias equal to true, it is able to identify the complex behavior with my data, right? So it has built a very complex model decision boundary to segregate my data point, right? So we have seen a clear difference between how the bias will impact your model performance, and now we'll try to understand why it has happened. What's the root cause of this poor performance? First, we'll look the original equation without bias, how it will look like. So if my neuron will not have any biases, the original equation of my output would be summation weighted average of my input value, and this weighted average would be passed to the activation layer, which will produce the desired output, right? But once the bias would be removed, then we can simply see this as a function which would be passing through the origin always. Now we'll try to visualize this equation from the 2D coordinate system perspective. Okay. So here in this diagram, you can see that if my line would be passing through the origin, so which means that it will have a less flexibility in terms of finding out the actual pattern within my data, because my straight line or whatever line it will have, it will not be able to move up and down, right? Because that's the role of bias. Once you add a bias in the straight line, your line will go up if it will have a positive bias, and it will go down, it will have a negative bias. And adding bias in your straight line makes it very powerful in terms of finding out real pattern within your data, right? And again, this bias is not dependent upon your input value, right? So adding bias will make model very robust in terms of finding out real pattern within data, and whatever is required, model can tweak that value to adjust or to find out the actual pattern, which will make the model more robust in finding out the non-linear pattern within data. So that's the actual role. Here you can see that once you'll add a bias, it will go up, right, for the positive bias. And similarly, if it will have a negative bias, it will go down, right? So in this way, model will have lots of power in terms of finding out the pattern within your data. But if we'll remove the bias, my model will have very less flexibility, and it will has a very limited number of combination where only this slope can change, right? It cannot move up and down based on your data requirement or whatever patterns you have within your data, right? So that's the actual reason why bias is important in your artificial neural network, and why bias makes your model more powerful in finding out any real pattern. Okay, so that's it for now. I hope you'll find this video useful, and if you haven't subscribed to my YouTube channel, please subscribe to it, and thanks for watching it again.